All right, so there we go. Couple things. So that 6 homeworks up there, it's a little bit shorter than some of the previous ones. Like I mentioned, if you haven't done one in the past, then I would highly suggest doing this one. That way, the one that you skipped before becomes your lowest and gets dropped. Right? If you've done the first 5 and you're okay with kind of your grades on those, you could not do the 6th. It'd be a 0. It'd be your lowest and it would get dropped. Right? So that won't really be reflected until after the due date for that 6th homework. Okay. So, those grades will get updated kind of as soon as that due date passes. So finals week, right, I'll kind of, as quickly as I can, kind of get everything kind of updated where I dropped your lowest and put up like this additional category, which shows kind of what your total grade was in the homework category with the lowest one dropped, right? But that obviously I can't do that until all 6 of the homeworks are over. So you'll see that pop up on finals week. And if you have any questions over that, feel free to kind of reach out to me. On files, if we go, I updated the week 15 lectures, so we're going to keep using them. So I guess I should probably call them week 15, 16 lectures, where we're going to kind of keep using them throughout this week. And then under final exam materials, there are kind of 2 sets of practice problems now. So these ones kind of cover a little more of the labor market stuff, and then some of the stuff that we're going to talk about today. Okay. Any questions from me before we get going here? Okay. So where we left off was thinking about reasons why wages might not be equal to the workers' value of their marginal product of labor. So we talked about unions, we talked about monopsony power, right? So maybe there's also some type of, what else is driving this income inequality? So, a lot of the times, we see potentially companies don't know right away what a worker's productivity is. Like they don't know exactly what it is. So they use all these other traits as signals, right, based off historical data, how well they think this person does, right? How well do people from these colleges usually do? How well do people with this degree usually do in this career, right? Right? They try to use all these other things as signals. So we can kind of look at, I don't remember if I showed you this last class or not, right? We've got a pretty wide kind of wealth inequality gap here, right? The top 1% owning, even at the lowest 30% of the overall wealth. And so how is this, how does this happen, right? So it's not solely being driven by union and monopsony power, right? And so we can think about different ways we can measure, right, the economic inequality in a county, a state, a country, the world, right? So a very simple example of this, right? So it's a little bit more complicated with more data. With more data, we probably need a little bit more experience in Excel or something like that. But with 10 people, we could at least get the principles behind what we would do to come up with these different measures. So the first is going to be, we're going to create a Lorenz curve. Right? So what the Lorenz curve is going to do is it's going to plot out some different points. So we're going to break it down into quintiles, which means like kind of each 20%. So we want to come up with, what is the bottom 20% of income earners, what percent of the overall income do they earn? And then for the bottom 40%, what's the percent of total wealth the bottom 40% of income earners earn? And then 60 and 80. And then finally, once we get to 100, well, what percent of the wealth would the bottom 100% of incomes earn? All 100, right? Once we get up to 100% of the individuals, they have to have 100% of the wealth. So we're going to come up with essentially these cumulative percentages, right? What percent of wealth does the bottom 20% own? What percent of the wealth does the bottom 40% own? So on and so forth. So in order to do that, we would need to take our 10-person economy, and we don't need to do this. It makes it a lot easier. Arrange it from largest to smallest, okay? So with 10 people, right, the percentages work out to be pretty easy. So if I give you an example, I'll give you like a 10-person economy, right? So it's not like I'm going to tell you, here's 47 people, find the bottom 20%, right? But with a 10-person economy, what would the bottom 20% of income earners be? That would just be the lowest 2 individuals. Yep, 10% of 10 people would be one person. So if we want the bottom 20%, it'd be the bottom 2. So what we could do is say, okay, for that bottom quintile, 0 plus 10,000, right? The bottom 20% of people here only own 2.6% of the wealth. And then what about the bottom 40%? Well, 25 plus 20 plus 10,000. So that's what, 55,000? Excuse me. So, excuse me. I need some water. So the bottom 40% of people here earn about 14.3%. So another way of thinking about this is I could come up with what percent Bobby and Cindy own, right? And then add that to the percent Alice and Sam owned, or I could just add all these up and kind of figure out what the percent is. Now, where are these percentages coming from? Well, once I added up all of these incomes, I would then just divide them by the total wealth in this economy. So the way I got this 385,000 is, right, I'm just adding up, this is the total wealth in this 10-person economy. So the percent that the bottom 4 people earn, right, would be actually, I should actually have all of these out front. If I divide 45,000 by 385,000, I'm not going to get 11.7. What am I going to get? 0.117. Okay, so, right, to change these to percentages in front of all of these, I technically should have, I'll move the decimal point 2 places, right? Or I'll multiply all these by 100, right? That way I get them in percentage form. Oops. And I think that's going to screw things up. Yep, that screwed up. I wasn't even looking. Oops. So I'll move these over so we can see these a little bit easier. So I basically just use this process. I go through, and for every quintile, right, bottom 20, bottom 40, 60, 80, 100, I just add up the wealth of all the individuals, divide by that total, multiply it by 100, and that would give me the percent. Okay. Now I could, like I said, break this down into each one of these quintiles, right? The top quintile owns 39% of the data or of the wealth. The second highest quintile, they own 28.6. But really what I'm interested in to plot this Lorenz curve are going to be these cumulative percentages. So just kind of adding up from where you're starting all the way down below. Just say a cumulative GPA. You take this semester and go all the way back to the beginning. So if I want the kind of bottom 80%, kind of start here and work all the way down, right? Add up all of these incomes and then divide by the total, and then that would give me that 61 point. Okay. So once I have these cumulative percentages, right, I'm just going to plot them out on a graph, right? So here, the bottom 20% own 2.6% of the wealth. So I plot 20, bottom 20%, Y value, percent of the wealth or income they own, 2.6. Bottom 40% own 14.3. So bottom 40%, 14.3. Bottom 60 had 32.5. So 60, 32.5, so on and so forth, right? So I kind of then drew out and kind of connected these points. And obviously I could do this much more granular. If I really wanted to, I could break this down to every single percent, right? The bottom 1% own this much, the bottom 2% own this much. I can make it a much more granular kind of curve here. But the idea is once I have this Lorenz curve, right, we can come up with this thing called the Genie coefficient. Okay? So what we'll do is think about this area under the curve. Actually, I'm just going to draw this out. It'll be easier for you guys to see. So if I'm thinking about, I've got my Lorenz curve. The reason why I have this 45-degree line where every point on this line, so anything about this would be 100%, 100%, and this was the percent of wealth. And this is like the percent of the population or the percent of my economy, right? The number of people here. What would this line represent if like every point in this line is 2020, 40-40, etc. This line would represent an economy that's in perfect equality, right? The bottom 20% of people owns 20% of the wealth, and the next percent, bottom 40% owns 40%. That's saying every quintile has the exact same percent of the overall income. So we would have kind of this, perfect equality. So the Genie coefficient is where we think about the area under this perfect line, right? What we're going to do is say that's kind of like our reference point. That's as high as it could ever be, right? So we'll call this, actually, how did I notate it in the slides? Okay, well, for now, don't worry about the slides. I'll break the slides down in just a second. So we'll call this the area under that 45-degree angle line, which kind of represents this perfect one-to-one relationship. That's that green area, okay? I then have this blue line, which represents my Lorenz curve, right? I was plotting out the percent of wealth that each different quintile owned. The area underneath that will be our numerator. So area under our Lorenz curve. We'll divide that area under the Lorenz curve by the total area underneath that 45-degree curve. So it's kind of telling us, like, as our Lorenz curve gets closer and closer, like let's say I had a Lorenz curve that looked like this. Well, now the area under the curve is getting closer and closer to the area under that 45-degree line. So the closer and closer to 1 our Genie coefficient gets, a Genie coefficient of 1 would mean the Lorenz curve has to be exactly equal to the 45-degree line. So if we can get this Genie coefficient of 1, that's kind of showing us that we're at this point where we have perfect equality. So what do you think the value for perfect inequality would be? This would be like if one person owned literally all the wealth. What would this curve look like? Well, if one person owned all the wealth, what percent of the wealth would the bottom 20% own? You say 0. What about the bottom 40%? 0. So you would literally have a Lorenz curve that looked like this. What's the area underneath that Lorenz curve? It doesn't exist. So that perfect inequality, you'd have this Genie coefficient of 0. 0 over, the area underneath that 45-degree curve. Okay. Now, I'm not going to make you kind of figure out these areas. If anything, it would be giving you a picture that said kind of the area underneath that Lorenz curve is this. The area under the 45-degree curve will always be this, which we could find that because if it's 100 to 100, well, this is the area of a triangle. So 100 times 100 times 1/2. So we have what? 10,000. So the area would always be 5,000, and that would always be our denominator. But mainly what I'm really wanting you to know is that the closer we get to 1, we're getting close to this kind of perfect equality line. And as the Lorenz curve kind of gets closer and closer to kind of being this real sharp curve here, we're getting a Genie coefficient closer and closer to 0 because we're getting closer and closer to kind of this perfect inequality point. I don't like how I explained it in the slides as much. So in the slides, I kind of broke this down. I was thinking about, well, you'll have the area under your curve and the area above your Lorenz curve, right? Those areas have to add up to the total area under the 45-degree line. But I think it's just easier to think about it as take the area under your curve and divide it by the area underneath that line of perfect equality. Okay. Any questions on that? So you'll see these, a lot of times you'll see these represented for different economies. So you just said kind of, I will use this one to make sure, see how people are following. So this will be the last iClicker that we use today. So from here, hopefully before next class, but for sure before Friday, I will get the iClicker scores updated to kind of display what your iClicker grade will be with the lowest 3 dropped, right? Currently it doesn't have any of them dropped. So once after today, I'll start working on that. But what I want you to answer here, which of these economies would be more unequal, or which one would have more income inequality, A or B, right? So remember what we were saying, right? What perfect equality and perfect inequality looked like. Right? There was a reason why we had kind of this red line drawn in. There was a reason we talked about why this 45-degree line represents. So which one of these, A or B, would represent an economy that's more unequal or has higher income inequality? Right? A smaller percent of people owning a larger percent of the wealth. You guys a little bit of time here. It looks like most people have an answer in. Everybody got an answer in here? 29. All right, I'm going to close it out. We're good? Okay. So let's see. Which one of these would represent an economy that's more, there's more inequity? Yeah, so which one would have more economic inequality, right? Or be more unequal? Yeah, right? So as we're getting a curve that's closer and closer to like this right angle, right? That was where we said that was perfect inequality, right? Perfect inequality was if we had this kind of not even a curve really, right? So as our Lorenz curve approaches that, right, we're going to be approaching a more and more unequal economy, or an economy with more inequity would be another way of saying that. Any questions on that? Is it clear why that's the answer there? Okay. So, got some of this measure out of the way. Oh, which would also imply, well, we don't have to worry about that. I'm not going to throw stuff like that in the exam, so it doesn't matter. So, I talked already about, we're talking about, this inequality exists. Now we know how to measure it to a degree, right? We can compare across counties, states, or countries, but maybe we want to understand a little more, why does this inequality exist, right? Excuse me. If I can get this to work. There we go. So I'll show you one example, which is wage differences to human capital. So human capital, right? I kind of introduced this idea of capital last class, which is like, usually we think of it as like machinery or anything that's kind of related to the production process that's not labor. So human capital is something that the labor force can use to increase its productivity, right? So human capital is really just another word for like education, right? Skill acquisition, anything where the worker is kind of improving their intellectual ability. We usually reference this as human capital increases. So let's think about a labor market. Where we're going to actually kind of draw two labor markets over each other. So first we'll start out with, well, we'll do an easy one first, then I think I'll show you that one. So we've got our supply and demand for labor. We've got our equilibrium quantity starting out and our equilibrium wage to start out. So if we recall that the demand for labor is the price of the product times the worker's marginal product of labor, if human capital makes a worker more like skillful or more productive, that's going to do what? The demand for labor. Well, marginal productivity of labor, that worker is going to become more productive with its human capital. Right? So they're going to essentially increase the demand for their labor. Right? Actually, I'll call this demand 2. And we kind of think about for those workers who are able to add human capital, they're more likely to be employed, right? There's more of them that employers would like to employ, and they're going to get higher wages. And that intuitively is what we kind of see play out in the data, right? On average, people with a college degree earn more than those that don't. On average, there's more of them who are kind of companies would like to employ versus not. Because they just add more value to the company, right? If that worker is more productive, for instance, even at like the lowest level, if I'm thinking about, give you a good example. So if I'm thinking like retail, so like these department stores, I mean, half of them are all shut down in Muncie now, but like JCPenney, right? Or like all these places, Macy's in the mall, they still exist in like Indy, right? But they're workers, right? That are just working retail. They're really just working a cash register. They're kind of doing some stocking, right? They're doing these different various activities. And you could probably have someone with low human capital who's able to do that job fine. But if you can find someone with higher human capital to do that same job, right? And they understand, oh, well, this is the marketing strategy here. This is why, they're having me do this. They can be more effective at their job, potentially increasing sales, right? They know, they're just a more productive worker, right? And so human capital, no matter what position we're talking about, we would always expect to see this kind of increase in demand for that worker, right? As a company, I'd be willing to pay that person a little bit more. Okay? So this is what we're kind of doing with education, right? You're trying to increase your marginal productivity, or at least signal to employers, that you are able to be a more productive worker than someone else, right? That's why, hopefully you're beating everyone else out to get the job that you apply to. Right? But what might also be true, which is kind of interesting to think about, is if we look at the percent of people that have a college degree, I think it's still roughly like 30% or just over 30. So what's true is there's probably fewer people out there that have a college degree than those that don't. Right? So not only have I increased the demand curve, right, we also think that that's probably, once I'm in that category of having a college degree, signaling that I have this huge human capital increase, it's also likely that, and I'll do this one, sorry, in the third color, I've now also put myself, we'll call this degree owners. I've now also put myself in this group where there's just a lower supply of us. So now, if there's a lower supply of degree holders than non-degree holders, well, then the equilibrium quantity and wage won't be these two, right? The equilibrium quantity and wage, if in fact I end up in a group where there's fewer of us, right, or degree owners. Now, this is where, call this Q3 and W3. It's not necessary that we will have fewer workers, with a degree versus non. It kind of depends on the size of these shifts. So this goes all the way back to supply and demand shifts. Notice the demand shift. So our demand increase, well, I should have kept these colors consistent here. The demand increase, right, caused quantity to go up and it caused wages to go up. That supply increase was causing wages to go up. So our supply decrease was causing wages to go up, but forcing quantity to be lower, right? So this is one of those where we have two effects. They're both driving up wage, pushing quantity in other directions. So what we could say, like, our total effect was of getting a degree, it shifted my demand curve, it put me in a group where there's a lower supply. The total effect would be that wages go up, but we can't really say what happened to quantity, right? It depends on the size of those shifts. So, you're kind of getting like a twofold improvement there. Like getting a degree, you're increasing your human capital, you're becoming more valuable to the employers. So the demand for your labor goes up, that pushes wages up. But then you belong to a group where there's just fewer of you, so the supply is lower, which also pushes the wages up. Think about if there's fewer of you out there, right? There's kind of like you have more power against these companies, right? In the sense that they can't just look at you and say, well, yeah, we're going to go turn around and find another. That's just like an intuition to kind of remember that. But if we kind of look at the graph, we've got a pretty nice visual there showing kind of wages being driven up twofold, right? By this decision to get a college degree. Okay. Any questions? And this is like if we're thinking about like holding the degree constant, right? We could do different things, right? Like we could draw similar things out, but maybe I draw the supply and demand curve for different labor markets, right? One for jobs where maybe there's a finance degree, and maybe one for I don't know. I don't like to pick on any degrees, but let's say we had a degree in I don't know, basket weaving or something like that, right? It's probably the major choice is going to matter as well. But right, we can understand those labor markets simply by kind of figuring out what the value of the worker is to those companies, and then also kind of what the quantity of supply would be there. Okay. Any questions on this? I got a couple things going on here at the same time, but I thought that was an interesting example to kind of work through. So I kind of have everything here, just the bullet points of what I said, which is, thinking about skilled versus unskilled, or someone getting a degree versus non-degree, differences in supply that could exist, right? That kind of, double that wage increase we'd expect. And I had a blank slide for what we just drew up there, but if you print those out, otherwise you probably just wrote it down in your notes. So one thing that we could think about that really worsens this impact is something called skill bias technology changes. Okay? So if we had what we had before, we could actually simplify this even a little bit more and really make this point of what a skill bias technology change is going to do. So we'll come back to this slide in a second. I just want to draw out the setup for what we have. So let's assume, right, that the amount of skilled and unskilled workers, so we're going to step away from this degree thing and just think about it as skilled versus unskilled. If it helps in your head, you can think about it as people with a degree versus those without a degree. But this could be something where like you're looking even within an industry, right? So there's people who maybe work in a factory that don't have like welding skills, right? And they're not valued as highly as the people who do. Right? So it doesn't have to be a degree. So let's assume that the supply curve for labor for skilled workers is the same as for unskilled workers, right? So we've got identical supplies. And let's think about, I've got my demand curve for labor for unskilled, the demand curve for labor for skilled. So this would predict just off, before we have any technology changes, we would expect there to be a wage gap between skilled and unskilled workers. So already this idea of being skilled versus unskilled, or just being valued more highly by the company because of, you're more productive, that's already going to be driving wage differences, right? Just the fact that we have some workers who are more productive than others, that's going to drive some wage differences. Or I shouldn't say more productive, have different skill sets than others that make them more productive. So we're just going to focus on wages here. We could look at the quantity of labor here, although that's not the point that I really want to make. So let's say we have this skill bias change, right? Or skill bias technology change, where we have a technology improvement, but it only really helps increase the productivity of my skilled workers. So this could be something like, we think about the value of the marginal productivity labor, that's only going to shift for my skilled workers. Well, that value of the marginal productivity labor, that is my demand curve for labor. So I'm going to see this increase in demand for my skilled workers, and my unskilled workers, right? The value of their marginal productivity, this technology didn't impact them all, so it's not going to change. Okay. Whoops. So what that's going to look like is the demand for unskilled labor stays the same, wages stay the same. However, the demand curve for skilled workers, they're able to use this new technology, we'll call this 2 stars, right, to kind of show that it pushes that wage gap even further. There already was a gap to begin with. This new skill bias technology really just widened that gap. So where we saw this play out within like the last, I would say 20, 30 years, or probably maybe go back a little bit further, maybe 40 years, right? If you were a skilled worker and you were able to understand kind of the new technology that was coming out and utilize it to become more productive or effective, things like computers, right? Working with big data, all these other things, then you were able to really push your wage up from these unskilled workers. People who were not able to adapt these new technologies, well, they didn't become any more valuable to the company, and so their wages kind of stayed where they were, right? So because of these individuals who were really able to use technology, right, and whatever their skill set was, we saw these wage differences kind of really start to grow between our kind of skilled and unskilled. Or you want to think about it as like, degree versus non-degree holders, or kind of people on the right side of the intellectual distribution versus those on the left, right? These new technologies even kind of further exacerbate this difference in wages for these skilled groups. Okay. Or groups with human capital versus not, however you want to think about this. Okay. Does that make sense? Any questions on this? Okay. Also, we're not even going to touch on this in this class, but if you were to take like the labor econ course here, or even intermediate micro maybe, there's this trade-off between labor and capital, right? So like if my wages get high enough, right, if I am not productive enough and my wages are more expensive than what it would cost me to buy a machine to replace me, what do you think most companies do? They buy a machine to replace that worker, right? If they can get something that costs them less, but is more effective than their current worker, they replace the worker with what we say capital, machine. So if you can increase your productivity even more, you just make that less likely, right? The more and more I increase my my skill set or kind of adopting technology and make myself a more productive worker, it's less likely I'll be substituted out by machinery. Although that's the hope. Although I feel like we're like creating, I feel like the individuals in this skill group are now creating the technology that will replace them, because you know, computers can think much more effective than we ever can, right? So that may be an issue in the future. But this is a good example of kind of showing how, you know, if there's one group where that can utilize technology versus not, they could drive their wages up quite a bit. So, you know, if we look at this, we can think about this as degrees. You know, we see it play out in the data. I mean, in terms of weekly earnings and unemployment rates, this is some older data, but it was pretty good from the Department of Labor, right? If you just work your way up the degree ladder, weekly earnings, I mean, really other than, you know, looking at the difference between a professional and doctoral degree, and that's probably driven by the fact that some doctoral degrees probably aren't as useful. But pretty nice, you know, pretty nice visual here. You can see earnings increase, right? Which is really what we were talking about with wages, right? The earnings kind of represent those wages, so they should be higher. They also mean that it's kind of less likely that you're unemployed, right? What I was just describing, you're less likely to be replaced with capital. There's, you know, the supply of workers is lower out there, and so, you know, your employers really have to compete to get you to work for them. So we kind of see here as we go up that education level, right, or build skills, less likely we're unemployed, more likely we earn higher earnings. Okay? Although this should not be surprising, right? But this is kind of lines up with what we've been talking about. And I guess I had two slides in there that skill bias. We already kind of worked through this. I think this was left open for you to draw what I might already drawn. Is there anything else I want to do here? So, you know, you could think of things where we could compare. It's kind of an easy one, I think. Let's say that another interesting issue we could think of. Quantity of labor, wages. Right? Let's say we've got supply for labor here. We've got the demand curve for labor here. And we'll think about here. This is going to be citizens of the United States. So if companies don't care where their workers are from, right? All they care about is the productivity measure. Right? If I'm looking at this and say, okay, for an American worker, I'm going to have to pay this wage. Right? And let's just say that, you know, remember that our supply curve represents marginal costs. And what was the marginal cost? Most of the time, it's like what we're giving up in terms of how much we valued the hours we're giving up for labor if we instead could have used them for leisure, right, to do something else. Okay? So, you know, the idea is we give up our least valued hour first, then our next most valued, et cetera, et cetera. Right? And maybe Americans kind of view their leisure time as highly valued. Right? So maybe you've got people who come from other countries who are in very, like, way worse economic conditions. So when you ask, okay, to get this same amount of labor, what would they be willing to work for? It's likely that people coming from these impoverished countries would be willing to supply the same amount of labor as a US worker, but at a much lower cost, right? Much lower wage. Because their outside option is not that their parents are going to let them live with them until they're 35, and right, like the economic conditions are so bad that they'd work for a much lower amount. So we end up with a supply curve for labor. It's actually higher, right? So it's not higher because, so we can call this kind of like immigrant workers. So it's not higher because there's more of them necessarily. It's just higher because there's more of them who are willing to supply their labor at these low amounts. So what ends up happening is you see kind of a lot of these immigrant groups come in, they're willing to work for lower wages, right? So it's not that, it's like, I think sometimes people like, I mean, it's not necessarily ineffective for the economy, right? Whatever group this is, maybe this isn't, U.S. citizens versus immigrants. Maybe this is like, I don't know, baby boomer generation versus millennials or something, right? You can compare whatever groups you want. If one of them is willing to supply their labor at much lower wages, well, you're going to end up with an equilibrium wage that's lower, but that's not necessarily a bad thing, right? That's just coming out of the fact that they have, would be willing to supply their labor at lower wages than this other group, right? So we'd expect maybe that whatever market this is, the quantity of U.S. citizens we see relative to immigrant workers that we see, right? Potentially fewer kind of American citizens in whatever labor market this is. Okay? Because, if the companies aren't discriminating, they don't care. If here, I guess what I've done is I've assumed both groups are just as effective as each other, right? Whatever job this is, it doesn't matter if I had, I don't know why it ever would, but, they're doing the same job. We're comparing a worker with the same productivity level. All the company cares about is kind of the value of that worker's marginal productivity labor. And that's no different for these two groups, right? Because if they both had the same marginal productivity labor, they're both equally effective. The price of the product doesn't change, depending on what worker I have. And so here we would kind of see a prediction of why we maybe see some of these, why we see lower wages for groups coming in from poorer kind of economic conditions, right? They're just willing to supply their labor at lower costs. What else did I do? We do immigration. The other one I had thought about was, could do discrimination stuff, but I don't know if we have enough time. I think I'll show you one. Oh, we'll call it for today. We'll get out a little bit early. I'll kind of keep next classes like self-contained. So what we're going to talk about on Wednesday is we're going to try to look at discrimination. So I also might put a paper up that we'll talk about a little bit on Friday. But if I do, you don't have to read it before Wednesday's class, but I might get it up there at some point tomorrow. But we will probably go over it on Friday. There's not going to be like, I guess it's more of you humoring me because I'm not using the eye clickers anymore, but it's something that we might talk about in class. You might want to take a look at it. Hopefully it's kind of interesting. It'll be me kind of showing you what research in economics looks like. And then we'll probably start some review even on Friday as well. Okay. All right. I will see you guys on